Hello, welcome to this tutorial. My name is Benoît Rognier. I am the co-creator of the Completium tool suite. In this tutorial, we are going to see how to develop a decentralized application, a DApp, on the Tezos blockchain. First, let's have a look at a simple DApp architecture. There are three main elements: the smart contract, the user interface, and the wallet. The wallet is responsible for keeping secret the account's private key. From a functional perspective, the task of the wallet is at least to sign the transaction, and usually it does much more. It sends the transaction to the blockchain, and it even allows using physical wallet like the Ledger one. In this tutorial, we are going to deploy a smart contract on the Tezos testnet, and we are going to build a simple interface to interact with it. For that, we are using some tools from the Completium tool suite. First, the Skeleton DApp project. This Skeleton project comes with a wallet button and a settings panel to connect to the blockchain. Then the archetype language to develop the smart contract, and the Completium CLI to deploy and interact with the contract from a command line. Links to the documentation of these tools may be found in the description below, and the tutorial we are going through is available on the Completium site at completium.com. The decentralized application we are building interacts with a smart contract, which is a title of ownership of a digital asset. And the contract provides an auction process to transfer the ownership to the winner of the auction. Okay, so now let's go to the tutorial itself, available on the completium.com site. So for this tutorial, you don't need to install anything because there is a Git pod environment set up with the Completium tools. So just click on the Git pod button to launch it. So it will just require a GitHub or GitLab or Bitbucket account to log in. So this environment is set up so that the Skeleton DApp project is compiled at the launch time, and so this environment is set up so that the Skeleton DApp is compiled and launched at startup. Okay, it's now compiled and now it's starting. So the initial interface is displayed here on the right-hand side panel. Here we are. Okay, so this is the initial interface of the Skeleton project. So the first step of the tutorial is to deploy the smart contract. So the code of the smart contract may be found in this section here. So the smart contract is written in archetype language. So archetype is a high-level language that was specifically designed for smart contracts. It provides dedicated abstractions that made the code of the smart contract short and easy to read. A detailed presentation of the language will be the subject for another video. So the contract stores the digital asset ID. It stores the current owner of the asset, and it has a binary state which says whether the asset is for sale or not. Okay, besides that, it provides 3 entry points. Up for sale. To put the asset up for sale, it is called by the current owner of the asset. The second entry point is bid, for anyone to place a bid when the asset is for sale. And the last one is claim, to transfer the ownership to the winner of the auction. It may be called by anyone when the auction is over. Okay, so to deploy that, you can just copy paste in the Gitpod environment. So just create a new file here that we're going to create right now. Just copy paste the source code. Okay. And to deploy it, you can do that in a new terminal with the Completium toolline. So Completium is already available here. So here we now have to import a faucet account. So a faucet account is a test account that comes with fake Tezos for you to interact with contracts. Okay, so let's go to the site. Just click that here. So here we are. Now you can just import it with the command Completium CLI import faucet. Then you can put the JSON file, and here you have to say you have to give an alias to this account. So let's call that owner. Okay, so the owner account is now registered. We just need now to switch to this account, to declare this account as the current one used by the CLI. So for that, you just do Completium CLI, switch account, and then you see the top three here comes by default, and then you can just select the one we just imported. Okay. So now Completium CLI show account, it will show the current account. Okay, and you also have the current balance of the account on the testnet, which is at the time of recording this video the Florence protocol. Okay, so now the account is imported and set as a current account. We are going to set this account as a current owner. Okay, don't forget to save the file. No problem. So now to deploy, it's very straightforward. You just say Completium CLI deploy nft.irl, and that's it. So it's going to use the owner account. Okay, to just say yes, and let's just wait for the confirmation of the operation. Okay, so the contract is now deployed, and you see that the CLI provides you with a link to the Better Call Dave indexer. So let's follow the link to see the contract on Better Call Dave. So you see the owner, the asset ID. Here you have all the storage and all the bid claim up for sale entry points are available. It is also possible to display the storage with the Completium CLI with the command Completium CLI show storage and the name of the contract. Okay, here we go. So it's a raw version of the contract in a JSON format. Okay, so now we have deployed the contract. We now want to develop the interface to interact with the contract. So let's go back to the tutorial and let's move on to the next step, which is display contract data. So here we want to display the asset ID, the owner, and status information stored in the contract storage. So for that, we are going to develop a React component whose structure is displayed here. So the structure is a very standard React structure. It has a state managed by the use state hook. It uses the callback hook to store data, and the display itself is to be returned in the return section. So the contract data is read in the use callback data. And for that, we are going to use the Taquito library. So Taquito is a very convenient library to read contract data because it provides a plain JavaScript object as the contract storage. So this is illustrated here in the code. So once you've retrieved the contract object from the address, so then you get the storage as an object, so you can read straightforwardly by, for example, storage.assetID, storage.owner, storage.state. Okay, so very, very straightforward. Okay. So next step, we have to make the DApp aware of the contract data. So we have to set the contract address in the settings.js file. Okay, so let's do that. So here we'll use the command show contract to display the basic information about the contract, including its address. Okay, so let's go to the settings.js file, and let's paste that here. Okay. Then, so the code of the component to display data is available in this section here. So just copy paste the code and replace this fix me steps 3.1 by this code in the app.js file. So let's do that. Okay, step 3.1. So this one, just replace that with the code. Okay, and the next thing is to replace, well, to call basically this component from the app.js code. Just replace all that, all the UI, by a call to this component. So here, I think we just need to refresh that. Okay, so here we go. So now we have read this straightforwardly from the storage. Okay, so now we have displayed the data. We now want to be able to interact with the contract, so to call the contract, basically to place a bid. So for that, let's go back to the tutorial and let's move on with to the section bid button. So what we want now is to add a button to place a bid. So the code of this button is available in this section. And if we give a close look at it, we see that calling the bid method of the contract is actually only one line of code here. Okay, so with the contract object, you just invoke the bid, straightforwardly the bid method. Okay, so let's copy paste this, and let's paste this in the fix me step 4.1. Okay, so 4.1 is here, just paste that. Okay, and now we just need to, again, call this button, well, to display this button by replacing the fix me step 4.2 by this code. Okay, so the 4.2 is here. Okay, so here the thing is that we are not connected to the wallet yet. So we need to also add the button to connect to the wallet to be able to interact with the contract. And this wallet button is provided by the skeleton Completium React project. So what you just need to do is to call the wallet button and replace the fixme 4.3. So let's copy paste the call to this wallet button and let's put that here. Here is the wallet button. So it is able to detect whether the Temple wallet is installed or not. And if it's not installed, it links to the installation page. So let's follow the link and let's install the wallet temple. So let's create a new account. Okay. Okay, so here let's name it a bidder. This account will be the bidder, and we'll set that on the testnet, Florence testnet. Okay. So what we need to do now is to send some tags to this account. So let's show that. So we want this to have some account, so the owner will transfer, the account owner will transfer some tags. So let's do Completium CLI transfer 10 tags from owner to no, sorry. Yes. Okay, so let's pin the extension. Okay, so 10 tags were received. Okay, so now let's just refresh that. So now the wallet button detects that the Temple wallet is installed, and now it just asks to connect to it. Okay, let's take the bidder. So we will connect to the DApp with the bidder account. Let's connect. Okay, and now we can post a bid. So the value of the bid is hard coded in the file for the moment. It's let's have a look. Yeah, it's when we call the bid method, it's the amount is 10 TAS. Well, that's maybe I should have yeah, I should have put a little bit more. So yeah, 10 is a little bit is not enough. So sorry. Let's send 10 again. Okay, let's see. Okay, so now we have 20. Okay, so now we can try to place a 10 TAS bid. Okay, so let's connect. Let's post a bid. So here we have a confirmation pop-up, which is generated by the wallet. Okay, so let's confirm that. Yes, we want to place a bid. Okay, so here we get an error message which says asset not for sale. So actually, it's totally normal. It comes from this error message here. What we need to do first, we need to set the token up for sale. Okay, so let's call the contract as the owner to set the token up for sale. So we'll do that with the CLI. So we do Completium CLI call contract NFT. So the entry we want is up for sale. And the argument will be like, let's say that the initial price will be like 7 TES. Okay, let's do that. No, yes. Okay, so if we refresh that, yeah, we see now that the status of the token is now for sale. So that's good. So now we can connect again to the wallet and post the bid. And now it should be okay. Okay, let's confirm that. Okay, so now everything is fine. We are just waiting for the confirmation. Okay, so it's now confirmed. We can have a look at the contract storage in Better Call Dev, for example. So let's play the indexer URL again. Okay, so let's follow that. And let's see that, yeah. So now the best bidder is actually this address. So it's, everything is fine, and the best bid is now 10 TES. Okay, so fine. So last step is to wait for the end of the auction and to claim the ownership. So now let's add the claim button. So as for the previous buttons, the code is available in this section. So we just need to copy the code and replace the fixme 6.1. So again, the code to call the contract is only one line. Once you have the contract object, you just invoke the claim method. The unit value we see here as the argument means there is no parameter. Okay, so let's copy that back to the app.js file. Here we go. And we just need now to call this button on fixme 6.2. Okay, and here it is, the claim button. So now what we just need to do is to click on that button and claim the ownership for the digital asset. Waiting for confirmation. Okay, it's now confirmed. So this is the previous owner. So the new owner should be the bidder. So the one HYWP and so on. So let's refresh that. Yeah, okay, it works fine. The new owner is now the bidder, TZ1, HYWP1, and so on. Okay, so here we go. We have completed this first DApp tutorial. Thank you very much for following this tutorial so far. There is many ways to go further and to go better. I'm sure you have a lot of ideas to improve the interface. So feel free to do so. Do not hesitate to contact us at contact@educara.com. And thank you and see you next time. Bye-bye.